Oh, good day to you. This is the Math 8 TJ study guide for the Unit 2 CSA. It's October 30th, 2019. The test is tomorrow, October 31st, Thursday. All right, let's get to it. Use a picture on the right for the following questions. Using angle properties, write an equation. Well, let's take a look at what we know about angle properties. What I know about angle properties is if I have parallel lines, which I will call line 1 and line 2, and I know that line 1 is parallel, that's what this symbol means, then I know that this is a transversal line. I usually use a cursive T for it. I also know to label that this is the interior, and this is the exterior, and this is the exterior. The interior is the area between the parallel lines. That lets me know lots of things. When the parallel lines are here, I have some congruent angle properties. Okay. One thing I know about angle properties is I know that where the lines cross right here, I get a vertical angle. So this angle right here is 12x plus 10 degrees, because I know that vertical angles are congruent. Okay, what else do I know? And I'm looking at this obtuse angle here, and that makes logical sense. This is an obtuse angle greater than 90. I also know that alternate interior angles are congruent. So I kind of ran out of room right there. So if I wanted to, I could write this angle is 12x plus 10 and then do a vertical angle. But I also know that in this similar location, this angle, that angle is congruent to that angle. But I also know that corresponding angles, this angle that's left and down, this is left and down of the parallel lines, I know that corresponding angles are congruent also. So I know the three angle properties. I also know, and I don't have to apply it here, but I know about supplementary angles where you have a straight line, and we use that property of half a circle 180 degrees to find the acute angle. We don't need to find it right now. Right now we're applying the fact that we can go vertical angle, that's the angle symbol, is congruent, and we know that corresponding angles are congruent. And so therefore I could go across, vertical, corresponding, and now I could set this angle equal to that angle. So I've got a great convenience here that I know that 12x plus 10 equals 15x minus 20. Then part B says I need to solve the value for x. So I'm going to build a wall, and I cannot do any combine like terms, so I'm looking to combine like terms. I don't do that because it's already done. There's no like terms on the same side. There's no distributive property, so I'm going to move to inverse operations. And I'm going to subtract 12x from the left and subtract 12x from the right. Cross that off. Bring down all the things that you don't touch. The 10, the equal sign, 15x. We're going to subtract the coefficients. We get 3x. Bring down the minus 20. And now, it always tells us on our checklist to identify the variable and then do the opposite. So I'm going to add 20. I'm almost done. I bring down the 3x. I have it equals and 30. I ran out of space, but now at this point I can use mental math. What times 3 equals 30? This is multiplication. And so I know that x equals 10. I usually put a rectangle around my answer. And then we get to part C. Substitute the value of x into the equation to show that both the angles are congruent. This is also known as the checking step. So I'm going to take my original equation that I made up here, 12, but in place of x, I'm going to put what I got for my answer. 12 times 10 plus 10 equals 15 times 10 minus 20. Okay, well, 12 times 10 is 120 plus 10. 15 times 10 is 150 minus 20. I end up with 130 equals 130, and that checks. Sometimes I put a slash through my check. That would be a full point. All the points that you have an idea, or you can explain the angle properties, set up the equation properly, solve it for x, substitute, and check. Number 2. We have a typo that needs to be corrected in problem number 2. And I want you to change the word area here to perimeter on your study guide. And come down to the bottom here and cross off area and put perimeter. And now we can go back to the problem. Jamie is laying sod. Sod is a type of soil in her backyard. Her backyard is a rectangularly shaped with a perimeter of 72 square feet. We're going to get rid of this word square also and just put 72 feet because perimeters are not measured in square feet. They're measured in linear feet. The width of the backyard is 5 feet and the length is 2 less than 3 times an unknown number. So let's draw a picture to represent the situation. Okay, well, I'll just grab a straight edge here. You don't need a straight edge. You can freehand it, but I had a ruler next to me, so I'm just going to make a nice rectangle yard. 90-degree angles. Feel free to pause anytime you need to catch up. So she's laying sod in her backyard. Draw a picture to represent the entire situation. Okay, well, what do I know? Perimeter that's the distance of going from each corner to here, coming to here, traveling to this corner, and then back to the original position. So we know that this, we typically call the rectangle width for the short side and length for the long side. So the perimeter equals the width plus the length plus the width, again, there's another width here, plus another length. Or another way to say it is that it's equal to 2 widths plus 2 lengths. There's one W there and another W make 2W, and one L and another L make 2L. Let's see how the width relates to the length, though. And how far is the perimeter? Happens to be 72 feet. Okay. The width of the backyard is 5 feet. Oh, so I can put 5 here. And the length is 2 less than 3 times an unknown number. So 3 times an unknown number is 3x. And less than is minus 2. When it says less than, the minus sign comes after the other term. So now we know that this is 5, so we can put it in here. 72 for the perimeter, the entire length around, and I'll show you an alternative way to add this up. This is the way for the equation, but I'll show you a mental math way to solve it too. 72 equals 2w plus 2l. Well, that's 2w plus 2. We know the length is 3x minus 2. Okay, we also know that the width is 5. 2 times 3x minus 2. Okay, we need to distribute this. Now we're over here. This is going to be writing the equation. 72 feet equals 2 times 5 is 10 plus 2 times 3x minus 2. Now we can solve it. Okay, 72 equals 10 plus, and let's distribute, 6x minus 4. Now we have combined like terms here before we do any inverse operations. 72 equals 10 minus 4 is 6 plus 6x. Sorry, let me make it more like that. The product of 10 minus 4 is 6 over here. This 6. Okay, and then we subtract 6, and we get 66 equals 6x. We would divide by 6, or just recognize using mental math that x equals 11. Okay, so we already knew that the length was 5 feet. Now we need the length. Well, the length is 3 times 11 minus 2. 33 minus 2 is 31. Sorry, I ran out of room. And it's important that we put what units it is. It's in feet. Okay, let's imagine if you were really struggling with writing the equation, you could still get some points here because you could think, what is the total perimeter? So this is an alternative way to kind of get some points here. We know the total perimeter is 72 feet. And then if we wanted to know, we know that the width is 5 and this other side is 5. So the total width is 10 feet for the total width is 62. Okay, so that's how much two lengths are. Two lengths equals 62. So you know that one length has to be 31. And then you could start thinking backwards again. Well, you know that one length is 3x minus 2, then would be equal to 31. If you add 2, 3x equals 33, and x equals 11. So this is an alternative thinking. And showing a lot of that would be nearly, you would gain probably more points than if you didn't attempt any of the answers. Okay, turn your paper over. I have a printout where I have a second paper. And now we have some open-ended questions up here. And you have the opportunity to write an equation with one variable that has one solution. What do we know about those? The coefficients on both sides are different. Okay? An equation that has no solutions, the coefficients are the same on both sides. And the constants are different. And then for an infinite, the coefficients have to be the same. And the constants have to be the same. Okay, so we could work it backwards if we wanted to, and you could work it backwards, or you could come up with your equation up here. You could do something fairly simple, or you could get more complicated. Let's work it backwards. Infinitely many solutions. Let's just start with some. You can start with any number you wanted, but let's say you had 12 equals 12. And let's go to no solution. Let's go with 12 equals -4. We know that's false. And then here we could just do x equals 14. And then we could work our way backwards instead of working our way forwards. And we could add in some variables in here. We could go ahead and put in 3x. This is infinite, so they have to stay the same. Plus 12 equals 12 plus 3x. And I could start having some more fun with this. I know that I could make up a number. What's something that adds up to 12? I could have 16 minus 4. That's still 12, right? Equals 12 plus 3x. And here I could have x plus 2x plus 16. All right, now I'm getting somewhere. Let's imagine that I took a 2 out of that. I would be left with x plus 8 minus 4. So I just did the same thing. I just took a factor to 2. It's the opposite of distribution. And I could do 12 plus, I could have fun with this too. I could make it x, let's make it 5x minus 2x. That still adds up to 3x, doesn't it? Okay, so now I have an equation that will have infinitely number of solutions. So I just go ahead and write that up here. X plus 2 times x plus 8 minus 4 equals 12 plus 5x minus 2x. And I could do the same kind of similar things to here. At this point, you got to make sure that the coefficients are the same. So you whatever you pick for x, if I pick 6x plus 12, this other side has to be 6x minus 4. Because remember, the coefficients have to be the same. So now I can have some more fun here. I could make this negative 2x plus 8x plus 10. Well, let's make it even more fun. Let's go, well, let's keep it simple. Plus 16, but then I'd have to subtract 4. That keeps it balanced, because that, if you track back, here I could do, let's go to negative 8x minus 4, but I need to get back to 6x, so I would add 14x. And if I track back even more, having more fun here, let's leave the negative 2x here. What if I put an 8 out? That would be 1x plus 2 minus 4. And then I'll just leave this side by itself. Negative 8x minus 4 plus 14x. I have my equation. I can just rewrite it up here. Negative 2x plus 8, x plus 2 minus 4 equals negative 8x minus 4 plus 14x. And I can now do this with this problem. Now this problem I don't need to create x's, because remember the coefficients have to be different. So let's say if I made this minus 4x equals 14. So in order to keep it as a 1x, I'd have to put a 5x right here. Okay, now I can have even more fun with it. I can, let's say I put 5x minus 4x. Let's add 8 to this side. Equals 14. I'd have to add 8 to that side, the right side. And I can combine those together. Or maybe not, I just leave it. That's fine. That's an equation that would work. 5x minus 4x plus 8 equals 14 plus 8. Okay, so that would be all the points there. And here we have, use the picture to the right to answer the following questions. Using triangle angle properties, write an equation to solve for x. So we have to remember the two main triangle angle properties. One is that angles inside a triangle sum to 180 degrees. That's the first one. The second one is that we know that here's this angle right here. This is an exterior angle. We know the property that the remote interior angles, the farther ones away from the exterior angle, are going to equal that exterior angle. So the triangle exterior angle equals the sum of the remote interior angles, the faraway angles. That's what this word means, remote. Using triangle angle properties, write an equation to solve for x. Well, this makes it very simple. This exterior angle equals the sum of these two over here. So all we have is 145 equals 9x plus 4 plus 10x minus 11. So I end up with 145 equals, okay, I could drop all the parentheses here because there's no distribution going on. So I'm just going to write as 9x plus 4 plus 10x minus 11. And now I've written the equation. I'm going to combine like terms. I'm just going to kind of come down into this area. 145. Okay, 9x and 10x is 19x plus 4 minus 11. Oh, I can add these two. They're a like term. 145 equals 19x minus 7. So I'm going to add 7 here. And I'm left with, I'm out of room here. 152, I'll have to go over here. 152 equals 19x. Okay, I'm going to multiply by 1 over 19. I get 152 over 19 equals x. And I'm going to need a calculator. 152 divided by 19. Oops, I hit times. 152 divided by 19 is the number 8. So x equals 8. And now I have one more thing to do. I need to substitute back and find the angle A. So I'm going to write angle A equals 9 times 8 plus 4. 72 plus 4 equals 76. And I'm going to put a little degrees in there. Does it look about right? It's an acute angle, so that looks good to me. Now let's find angle B. It's 10 times 8 minus 11, which is 80 minus 11, which equals 69 degrees. All right. Now, there is one way to find out. If I put 76 degrees in here, and this one is 69, this is, okay, let's take a look at what this is. This is a straight line. So from here to here is a circle, half a circle, that's 180. So I need to subtract 180 from that. This is 35. They should add up 35, 76, and 69 to, let's see, 35 plus 69 plus 76 is 180. So that works. That's perfect. That would be a full point score on this problem. Finally, we get to the last problem, which is your essential question. How do you solve linear equations? And we know that to solve them, first, you do combine like terms. These are the things you do in order. Then you do distributive property. You always do these two things before you move to inverse operations. Remember, under these two things, you are regular PEMDAS. You're going parentheses, exponent, multiply, divide, add, subtract. Once you've exhausted all that, you end up in inverse operations. And since we're doing the inverse, which is the opposite, at that point, that's when you switch and you do things backwards. Sad. Yeah. Okay. And then you have a central question too. What are the possible solutions to a linear equation? And how could you determine the number of solutions without solving an equation? Which brings me to the point that I have given you the answers to that. They were in the classroom, but I've also printed out the answers for you. If you would take your study guide that you were given and then turn it over, you can see the second solution, the answers to essential question 2. Linear equations can have one solution, no solution, and infinitely many solutions. However, that will only be a 1-point answer. A 2-point answer has to give the 3 cases. For one solution, the coefficients are different. Case 1. Okay, if I was to solve this problem, you're going to get x equals -4. So you can feel free to solve this. No solutions here if the coefficients are the same. Now let's realize that you have 10p minus 6p minus 6 equals 12p minus 24 minus 8p. You get 4p minus 6 equals 4p minus, well, I made a mistake. Sorry, 12. Plus 12. I saw that problem too many times yesterday as a mistake. The coefficients are the same. The constants are different. Positive 12 is not the same as negative 24. So that's why they are no solution. Now, if the coefficients are the same and the constants are the same, then you have infinitely many solutions. So in this case, as I distribute really quickly, 32q minus 40 minus 7q equals 25q minus 8. It doesn't quite look the same yet, but when I combine these two guys, I get 25q minus 40 equals 25. Oops, I made a mistake. I forgot to distribute here. 25q minus 40. Now in this case, coefficients are the same and the constants are the same. So you have infinitely many solutions. So you'd have to give these 3 definitions here, here, here. You would have to memorize those to get the 2-point answer. Okay, well, good luck on your studies. I hope you do very well.